This video features a demonstration of ProVision. ProVision is a low-cost modular virtual reality system designed by Division. Virtual reality, or VR as it is often known as, is an interactive real-time experience. By means of user interaction, objects in a computer-maintained database are retrieved, manipulated and displayed. We can see in the monitor a representation of what the ProVision user sees through his head-mounted display. Virtual reality consists of a real-time access database representing an environment and objects within it. Objects possess attributes that describe them and their permissible behavior. Attributes like size, position, orientation, color, sound, gravity, movement, and so on. These attributes can be dynamically updated. Body movements and head position are tracked by the virtual reality peripheral. The 3D mouse is used to control movement within the virtual reality. The front trigger and top buttons, in association with position and orientation information, are used to select and manipulate virtual objects. The mouse resembles a conventional joystick, except it contains a 6 degrees of freedom sensor, which generates real-time position and orientation information. A sensor of this type is necessary to project the physical hand into the virtual environment. Another way of controlling a virtual reality is to use a glove fitted with sensors to measure the flex position of each finger on the hand. This flexion information is used to recognize user-calibrated gestures, which relate to meaningful operations in the virtual environment. Select, pick, and drop are common gestures. The same 6 degrees of freedom sensor to that used in the 3D mouse is mounted on the glove. Thus the computer can generate a realistic representation of the hand. The user is wearing an immersive head-mounted display. It incorporates a pair of miniature colour liquid crystal displays mounted behind special lenses which give a wide field of view image. When driven with ProVision's real-time visualization channels, the wearer receives a strong stereoscopic impression which sadly cannot be conveyed in a video recording. Let's take a look inside ProVision. Modelling any aspect of an environment in a realistic and interactive way requires a lot of computer power. ProVision is a parallel architecture machine which dedicates groups of processors to specific tasks within the system. These processing systems are known as clusters. Separate clusters are dedicated to audio synthesis, visual image generation, body tracking, gesture recognition, and so on. The visual image generation cluster consists of a state-of-the-art pipelined superscalar floating point processor coupled to custom pixel shading hardware. The system offers performance in excess of 30,000 full-color Guro-shaded Z-buffered triangles per second per eye. This environment consists of a fish room entered by passing through a door in a virtual corridor. Division provide standard libraries which allow an application to create, modify and manipulate objects in a virtual environment. These fish have been assigned an automatic swim function. One of the many functions in a virtual toolbox allows animated sequences like these to be suspended for detailed examination. Another door from the virtual corridor leads into this radiosity environment, provided by Chris Patmore of Oxford University. The radiosity algorithm is renowned for its realistic lighting simulation. A radiosity simulation solves the energy equilibrium in an environment, given the absorption and emission characteristics and positions of all surfaces. Each surface is subdivided into a series of patches, the coloration of which is determined by the relative visibility of that patch to all others. The output of the simulation is a mesh of triangles with colour information embedded within each mesh point. This triangle mesh is Guro shaded in real time, allowing lighting conditions to be observed from any point. The chess pieces in the room may be moved at will. Once a piece has been dropped out of the window, the assigned gravity auto function embedded within the environment object causes it to carry on falling. All computer-generated footage on this video is captured live from one of ProVision's visualization clusters. Generating models of objects can be accomplished in several ways. ProVision can accept models of objects designed using a selection of leading industry-standard CAD packages. Here, a simple 3D model is nearing design completion in AutoCAD. Final adjustments are being made, and AutoCAD is displaying a wireframe of the model. A different PC-based CAD package shows the model slightly more interactively. Once the design is complete, the model is exported to ProVision using the supplied tools. In ProVision, the object can now be interactively manipulated and used with other objects similarly designed. Virtual reality technology, often regarded in its infancy, is in fact maturing very rapidly and has already found its way into various commercial and research applications. For this interactive kitchen design application, each type of unit was designed individually using AutoCAD on a PC. These designs were exported to ProVision, where a complete kitchen has been assembled to investigate issues of illumination and ergonomics. Any of the items within the kitchen can be picked up, moved and dropped interactively, like this frying pan. The lighting conditions can be adjusted dynamically to determine how best to illuminate the scene, without ever having to actually build it, thereby minimizing the potential for expensive mistakes. Certain behavioral attributes have been assigned to specific objects. For example, the cupboard doors are constrained to rotate only about their hinges. The drawers will slide open only along their runners. This slice of toast, however, is completely unconstrained. Note the accurate illumination on the wall and the shadowing beneath the table in this lighting environment design application, developed by Thorne's Central Research Laboratories. The lighting conditions are pre-calculated using a radiosity program. ProVision allows the lighting effects to be interactively examined from any position in the room.